Good morning and welcome once again to the group exhibit Hydrogen Fuel Cells and Batteries at the Hannover Fair 2016. We have the first talk this morning for you. Please do come in. We have coffee on the house if you need it to get going this morning. Please do also participate in the discussion. You can raise your hand at any time and I'll come around with the microphone so you can ask your questions. Starting off today, we have a talk entitled Progress in Finnish Fuel Cell Activities, the latest solid oxide fuel cell products. With me, I have from two different companies. From Convian, I have the co-founder, Thomas Hakala, and from Elcogen, I have the development manager, Matti Noponen. I apologize, and please help me welcome them to the stage.
Thank you. I'm glad to be here.
First off, apologies for my pronunciation.
No, it was excellent.
Yeah, you broke the ice.
Thank you for flattering me, but it was not. Anyway. So, you guys are from two different companies within Finland, and your technologies are complementary. It makes sense for you both to collaborate. Let's start off first with a couple of sentences about what your companies do. Would you like to start?
Yes. So Elcogen is a company that develops and manufactures cells, solid oxide unit cells and solid oxide fuel cell stacks. In brief. so the unit cells we sell for basically all the customers all around the world, and these products have been available for markets now for about 5 to 6 years. And the stack side, what we have at the moment is that we have just entered to customer evaluation projects.
Okay, wonderful. So you sell components, individual cells and stacks, which then get integrated by your customers into systems, and you yourself are a system integrator.
Yes, Convion is a startup company. We are 3 years old, and we develop and are going to commercialize fuel cell systems for commercial and industrial segment. That means these are large fuel cell systems. Large is obviously relative, but in fuel cells, tens and hundreds of kilowatts is a large system, and that's within our scope. We have our roots in Wärtsilä Corporation, which is a multinational global corporation. We used to do R&D there, and in the beginning of 2003 we were spun off as an independent company, and we're now ready to start demonstrating our systems with customers.
Wonderful, and we'll return to your demonstration project shortly, but we'll start from the ground up. So coming back to your individual cells, you mentioned these have been commercial for many years now, right?
Yes.
Yeah, so how many years have you been selling them for?
We started selling unit cells back to 2009-2010 timeframe.
And your customers are generally all over the world, or?
Yes, our biggest customer segments at the moment are in Europe. So in Central Europe, of course, in Finland also, where we do the stacks, and then in Japan. But there's also some customers from United States, and so it's global sales what we are doing at the moment.
Wonderful. And what made you then decide to also develop stacks?
It's basically added value to the company, so that we can also get more customers. Of course, it's a fairly long road from unit cell to the systems and then to real customers. So with stacks we can let's say shorten this road at least a bit.
Wonderful. And you have a standard product offering of stacks, or do you do it custom depending on a customer's interests?
We have basically two sort of standard stack. What we have, the other one is 1 kilowatt size stack, mainly targeted for micro CHP applications. And then the other stack type is 3 kilowatt size stack, which is then intended for larger systems. And these 3 kilowatt size stacks can be integrated to 6 kilowatt size towers, which we actually just starting to demonstrate next week.
Next week, wonderful.
Next week, yeah.
And your earlier stacks, when will they be on sale?
You basically can buy those at the moment. It's still for evaluation purposes, mainly the stack technology.
Okay, great. And since you've been around from 2009 for selling your cells, what does the manufacturing process look like? Is it automated?
It's still semi-automated. We have most critical parts we have automated already. So, for example, tape casting lines are automated. All the printing is done automatically. It's not fully automated lines still what we have, but we are gradually going to that direction.
And you're seeing demand ramp currently.
We are seeing quite nice demand for our product pull from the markets to our product, definitely. So that's why we are also increasing our capacity at the moment.
What are you increasing your capacity to?
At the moment, we have the unit cell production capacity. What we have at the moment, that is roughly to 10 megawatt annual production capabilities. So that is roughly something like almost 50,000 unit cells that we can annually produce. Then for the stack side, we have at the moment production capabilities up to 1 megawatt annual production, and it's not everything fully in-house still, but we are getting this direction as we speak.
Sounds like you're making a lot of progress. I'd like to come back a little bit to your technology. You work at, well, for solid oxide fuel cells, lower temperatures. They're still higher temperatures, yes. Right?
Yeah, we work at that between 600 to 700 degrees, as most of our competitors work above 700 degrees or even 800 degrees to 900 degrees. And the added value from being at the lower temperature range is that we can actually boost up the efficiency, electricity production efficiency by working at lower temperatures, but we can also make the product lifetime longer because all the corrosion processes usually are temperature dependent, and all the corrosion happens more quickly at higher temperatures. And then on the other hand, we can also select cheaper materials for our stacks, and also for the system side. So there's a lot of benefits of trying to reduce the operating temperature from the fuel cell stack.
So it lasts longer and is cheaper, so that sounds good. Does it limit you at all with what type of fuel you can use?
Actually not. We actually have, for example, what we have demonstrated, we have extremely good internal preforming capabilities, which means that we can use more effectively, for example, natural gas as a fuel in our products than usually at higher temperatures what the stacks are operated.
Okay, great. So I'd like to now bring this to the system level. So this is where you come in. You said you work at larger scales. So who are your targeted customers?
For our kind of a product, there could be quite different applications. We call it industrial and commercial segment because power output of from 50 to say 300 kilowatts is something that's applicable to many kinds of buildings, some industrial processes, some sort of institutional systems that require, for example, backed up or secured power supply. So these are not for individual residential houses, but for commercial and industrial applications.
So as in residential applications, they produce both heat and power. Do you generally target power applications or heat applications, or both?
The competitive differentiator for SOFC compared to conventional generators is obviously the electrical efficiency. But our system is a cogeneration system, so the heat is recovered or can be recovered. Of course, you don't have to, but it's a power generator that when well integrated with heat recovery systems can reach a very high total efficiency. So both power and heat.
Both can be used. And you've recently completed some internal testing showing relatively high efficiencies. Is that correct?
Yeah, that's correct. Last year at this same venue, we discussed about finalizing a design of a product and manufacturing of first unit. And since then, we've run some long-term exposure tests for our system, as well as a number of experiments and verification tests. We have now over 5,000 loading hours under our belts, and then we were able to verify both the performance, efficiency, as you mentioned, as well as functionalities relating to automation, security, safety, and reliability-related issues. One of the important things that we also wanted to verify in practice was the multi-fuel operability. That's one of the things that we as a team have in our background, in our DNA, in a way. You would say that we worked with different kinds of fuels and many different types of biogases where the composition may change, and we treat that as the norm, that the composition changes, not as a deviation. So SOFC inherently is fuel flexible, and if you can manage the flexibility, the variability of the fuel, then you're able to utilize this kind of opportunity fuels such as biogases.
One of the things that you measure is the emissions output. So it's not just the efficiency or reliability, it's the emissions output. Does that vary with the fuel that you put in?
Not really. Efficiency determines the CO2 emission, obviously. If you use a fuel with a certain carbon sort of characteristics, but the other emissions that are quite critical in distributed power generation, particularly in sensitive areas like urban areas, inhabited areas, where accumulated effects of other sources can make it quite intolerable to have a lot of, for example, SOx or NOx emissions. We measured these, and they don't depend on the fuel. We didn't expect to see much of emissions, but we wanted to have it verified by a third party, and now we have it in official results that they're not really preconditions for formation of NOx, for example, which is an emission that is associated to various health problems.
Nitrous oxide and VOCs, volatile chemicals, are important to reduce more so in an urban setting. And your demonstration project that you have going is an urban setting, isn't it?
It's an urban setting, yes. We later this year we will deliver systems to north of Italy, Turin, to a wastewater treatment facility where we will utilize the biogas produced in the process of treating the wastewater, and it's within a city of Turin or that urban area, and we will run. It's probably quite a unique concept that we will have quite a significant fuel cell power generating capacity on site in a biogas installation, and we will cover approximately 30% of the normal power consumption of the plant by own production, and majority or 100% of the normal thermal loads of the process.
This is a very interesting application because you use directly, your biogas fuel input is directly an output of the wastewater treatment plant, correct?
It is, yeah. It's but there are various streams of biomasses and waste streams everywhere. Often they get underutilized or not utilized at all because the low energy density of the feedstock. But if as with SOFC, scale becomes no factor in energy generation performance, then you can utilize even small sources of such feedstocks, and it's quite an interesting application because anaerobic digestion, which is the process of producing methane-rich biogas, it's a conventional old technology, maybe thousands of years old, but it's often, in waste processing, it's often used in very large systems, but now it's also possible to have this closed loop approach in smaller installations.
It seems like a good marriage. If this gas would be produced as a byproduct of wastewater treatment anyway, you're now using it in your system, providing both electricity and the processes need heat as well. So it's a good feedback loop.
Exactly. And wastewater is a continuous. Wastewater treatment is a continuous process. You don't stop suddenly. It's something that keeps running and it must be kept operational, and that's one of the benefits of local power generation, is that you can secure the most critical functions in this facility and make this infrastructure service more resilient to possible disturbances in the power infrastructure.
Right, because you can operate almost independently. If there's a power cut or something, it acts like its own generator.
There's a possibility of that, and further optimization of both biogas process and the treatment process. We can foresee a possibility of becoming a net producer, or at least self-sufficient, and it's a big achievement if you consider that as a municipal function, wastewater or waste treatment is one of the energy intensive functions.
Great, and I feel like that could be used in many different areas. It's not unique to Italy or anything.
Exactly. There are this kind of plants almost anywhere, and it's really an untapped market, because at the low end, low power end, the conventional technologies of piston engines or turbines, it's very hard to get them competitive because of the low efficiency, low power output, and fairly high maintenance compared to fuel cells.
Okay, great. So I'd like to bring it back together, because both of you are also involved in a European funding project working together that just began. Is that correct?
That is correct. We started common project roughly half a year ago. The intention is actually to bring Elcogen stacks to the Convion fuel cell unit also. And the idea is that by utilizing our stack technology in their product, they can actually boost the efficiency of the system to higher level. Also optimize certain balance of plant components in their system to reduce the cost for the whole system.
Well, it makes sense that you have the system components talking to the system integrators. Do you find there's a good advantage in this approach?
I think so too. The results that Elcogen has shown with their stacks are very promising, and our system architecture makes possible very deep integration of the system, and I think combining the two, we can really start to deliver on the promise of SOFC of becoming easy, sort of a carefree way of generating power almost anywhere at a very high efficiency.
That's an excellent vision. At this point, I'd like to open up the floor to see if there's any questions. And if there's not, I'd like to just ask one more quick question. I know it's a tough answer, but in 1 minute. So you're talking about joining in a partnership, your two businesses. Do you think the industry is leading towards a more vertical integration approach, or does it make sense to have individual, so system integrator and component manufacturer separate in the future, do you think?
What we at least think is that the industry will go to more horizontal type of activities, so that there will be a dedicated component manufacturers, for example stacks or unit cells that can be applied then to many sort of different sort of systems.
Yeah, I think currently the industry is at its sort of early stages, and there are different approaches. But we also believe that from, for example, risk point of view, it is beneficial for us to focus on the areas that we master, and then discuss with the best players in the other critical sectors for realizing the product.
Okay, so you predict specialization in the industry, and it's a good thing that you're partnering together and having good communication, and that's how the industry will move forward. Excellent. Well, thank you very much. We're unfortunately out of time. Please join me in thanking our participants today. Thank you.
Thank you.
So do stick around. We have, just in a minute, the next talk coming up. We have, continuing on a Finnish line, we have Finnish hydrogen know-how. We have from Volkoski, we have Taneli, and now Karen. Thank you very much.